But I will tell you, I know a lot of successful people. And there's a lot of opportunity, particularly if you live in the Rust Belt, if you live in anywhere in New England, in New Jersey, New York, areas that have a large legacy industrial base.
Right.
The best engineers I meet in the field, they're typically running the teams. They're typically engineering managers. So, by the way, for the most part, you get a degree in engineering, you're an engineer, right? But to be
Sure.
an engineering manager, you got to prove you know how to lead people and solve problems.
True.
And you don't learn that at college. And a lot of engineering managers I've met came from backgrounds where they started doing something with their hands, having that real world application.
Hello, and welcome to the Elevator Careers Podcast, sponsored by the Allred Group. I am your host, Matt Allred. In this podcast, we talk to the people whose lives and careers are dedicated to the vertical transportation industry to inform and share lessons learned, building upon the foundation of those who have gone before to inspire the next generation of elevator careers. Today, our guest is Allred Stearns, Sales Manager for Encoder Products, a supplier to multiple industries, including elevators. Allred started his technical training as a helper to his father, repairing tractors and other farm equipment in eastern Connecticut. After some time in the military and a close brush with school teaching, Allred became a technician working on servo motors, which paved the way for his current position. Allred credits much of his success to getting hands-on experience and is a big proponent of doing what you love. Allred, welcome to the show.
Thanks for having me.
Thank you. I'm excited. It's always a pleasure, and looking forward to talking with you again. And there's always something I'm learning, and I hope our listeners can learn something as well. But tell me a little bit about your early career path, and what would you say excited you most right out of high school?
Well, it wasn't elevators. That's what you're getting at.
I hear you.
For no other reason than I just knew no better, Grew up on with a dairy farming family in the woods of eastern Connecticut, and I just always loved the study of life. So in high school, I left high school wanting to go to college to be a high school biology teacher,
Nice.
and that's where it all started. But I did 4 years of that and got my teaching certificate and diploma. And I did that for about 6 months, and I love teachers. They're amazing human beings because I was bartending and waiting tables to pay for college at the time. And
Right.
I talked to one of my fellow teachers and said, "Hey, after all the fees and taxes and things, what do you make as a teacher?" Whoa, I make more than that on Thursday at the restaurant. So that was the end
Ouch.
of my teaching career.
Right.
And quickly said, "Oh boy, I got to do something different. What do I do with this degree in biology?" I'd always worked with my hands. My father taught me at a young age that hard work doesn't make you rich; it just makes you tired. So he
Right.
did not milk cows. He fixed the farmers' tractors. So I spent
Okay.
most of my childhood driving around in a pickup truck with a toolbox on the back. Handing my dad wrenches and socket drivers as he fixed, this IH tractor here or John Deere tractor there. So I was always good with my hands. And always, my favorite part of college was actually physics, learning the right hand rule and
Sure.
the current and Ohm's law and all of this. So I just applied that, and I got into a small company called Servo, which at the time was in Haddam, Connecticut. Now they've grown a lot, and they're in Middletown, Connecticut.
Mhm.
And the owner there taught me more than anybody else about how to be in business and about working on electromechanical equipment. So I spent 14 years there, left as a general manager, and got a really strong background in robotics,
Yeah.
specifically with servo motors and their related encoders. And we brought on three vendors that we were selling and purchasing encoders from, and one of those was Encoder Products. So after I left Servotech, it was to go try my hand at sales and
Right.
to become an outside salesperson and run a region of the country for Encoder Products.
So you were essentially, was it more of a technician then in your first career?
Absolutely. Yeah, I started there as a technician, and then I ran the AC servo motor shop, we called it. And then I ran the whole shop as we grew. I
Hmm.
was employee number two or three
Okay.
in a little one bay garage with a
Wow. Yeah.
car garage door on it. And now I think they have a 20-something thousand square foot building, and there was a dozen and a half employees there So the end of my tenure, I was running the day-to-day operations for the company,
Right,
which was
right.
a lot of fun. Still small, right?
Yeah, yeah, yeah. So in Encoder Products it became one of your vendors. How did you actually make the switch, if you will?
Well, a couple years into working for Servotech, it's always fun. I would call them very much a startup. The owner was very practical and still is very pragmatic, but also very good at estimating risk. And he
Hmm.
took a lot of risk, but he took risk very smartly. So it's always fun to be in that environment where you get to do cool new things. And the servo motor world is very secretive. Most of these motors are built in Europe or Japan. There are
Secretive.
some,
That's an interesting term.
yeah.
It's
What I
is
mean
it
by
like top
secretive,
secret or
no, no, not top secret, but secretive in a way where, which kind of like cars are now. You download a data sheet for a motor, it's not going to tell you what's inside of it. So if
right,
you're in the business of rebuilding servo motors, you're not going to find a manual. You're not going to go to Napa Auto Parts and get the guide of what the torque specs are for each bolt on
right.
that motor. You got to figure it out as you go. You reverse engineering, and
Okay.
there's a lot of the school of hard knocks in this type of thing. But we started investigating encoder companies because that's a major component in a servo motor is the
Sure.
feedback device. That's what makes it a servo motor, right? Closes the loop with the control. And we found some major brands of encoder manufacturers that would work with us once they saw what we were capable of. And we actually became factory authorized for some brands that had never authorized anybody before,
Right.
and for in the repair world anyway, for commissioning their encoders and installing them in motors. And Encoder Products was one of those.
Right.
I had become good friends with the outside regional sales manager, Bill Faison, who's retired now. Wonderful man. Still go to see him in North Carolina. And when he retired, they asked me to take his role. And sales has always interested me. I got a big mouth and I love to run it. And storytelling is half of sales after all. Um, so I jumped at the opportunity, and
That's
I
cool.
still work. In fact, Servotech is one of my customers. Very fond memories, and I still work with them.
Right on. No, that's cool. How did being in being a technician essentially prepare you for your sales role?
Oh my God. And I'm not the only employee of Servotech to say this. Towards the end, I was hiring our entry level technicians to train. Well, nobody goes to tech high school or even college
Sure.
to learn how to rebuild servo motors. And you have in Connecticut anyway, in the tech high school program, you have automotive departments, and kids who go to school to learn how to repair cars. You have electrical to be residential or maybe commercial electricians, and you have carpentry. And we would hire kids out of automotive or out of residential electrical because they understand how to use tools.
Sure.
They could read an ohm meter, and that's pretty important. And some of these kids now, I have kids that are not kids anymore. They're adults with families, and they're working in top secret applications, designing, uh, uh, you know, uh, uh, defense-related projects, and it's
Cool.
because of what they learn there. So my hands-on technician time at Servotech, just like theirs, was invaluable. You've got a lot of candidates being interviewed for sales engineers roles, for example, who have all the knowledge, but they have no wisdom. You know, so when they approach a problem, when you visit a customer site and they have a problem they're trying to overcome, you can only apply what you've already been taught. You
Sure.
haven't had to think on your feet and develop a new solution. So invaluable for sure.
Yeah. 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 Well, and it sounds like that, there's a lot of knowledge that is not being taught. So, unless you're learning it
Oh
on the
yeah.
job, unless, you bring it. So back to your teaching career, it sounds like you are in a teaching career. It's just not public schools, right?
Yeah, I do enjoy teaching, and that's one of this role I have now as sales manager. That's one of my favorite parts is helping my guys, improve.
Yeah. Yeah. Very much a teacher. Obviously not biology per se,
No,
but still definitely a teaching profession. And especially if someone maybe doesn't have the technical background, maybe you're hiring a salesperson and they don't have as much technical, you're probably digging into the technical to help them understand the whys and wherefores of what they're trying to sell.
exactly right. Yeah, definitely. And the biology aspect actually comes into play more than I thought it would. Because of the amount of medical device that we get into.
Okay.
And I
Yeah.
had no medical training. It was just a biology degree. But somebody comes in, oh, we're working on this machine that does PCR reactions. You say, oh, polymerase chain reaction. Are you doing genetic type work? And it's a very basic thing, but only if you're in that world a little bit. So
Sure.
that always helps me as a salesperson look a little smarter than maybe I am.
Right. 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 So, tell us a little bit about like the encoders, right? Obviously, that's what you're doing now, kind of on top of Servo. And I'm not, super technical but how does that work? And what's the application for elevators, for example? Or, I have no idea how it would work in a medical device thing either.
Gotcha. So, Encoder products specifically focuses on rotary encoders. And
Okay.
when most people use the term loosely encoder, they're typically referring to a rotary encoder versus something linear, like a scale that you would put a
Okay.
scale on something and measure. So, sticking to rotary encoders, they're a device that you use to measure speed or position or angle, which would be another form of position. And they're really elegant in their simplicity. We've all kind of made them already. If as a kid you threw a playing card in the spokes of your bike tire, you kind of made an encoder. If you could actually listen and count the clicks of every time your card hit the spoke, and you knew you had 60 spokes on your wheel, well, hey, I heard my card flick 60 times.
You're
I've done a full revolution.
ticking out a beat there.
That's exactly it. Yeah, yeah. That's a good way to put it. That's all we sell. So I sound much smarter than I am many times because it's in robots, right? It's used for
Mhm.
extreme positioning, and you see these very complex automated systems screaming around, making products. Elevators, moving around, positioning themselves very accurately, and they think that must be a really technical product. It's a disc shining a light through it, and there's lines in the disk, and you interrupt the light, and you're counting those interruptions. And now you can have all these boards that give you all these protocols. Well, I need my encoder to speak CAN because I'm putting it in a truck and all the vehicles operate on a CAN bus. Or I need it to speak EtherCAT because I'm working with a system that takes that protocol. Or I need an
Right.
SSI protocol. NDAT is very big in the elevator industry, as a matter of fact. And I need my encoder to speak NDAT. Well, that's just a communications board of the
That's just a
language it
protocol.
speaks,
Okay.
but the guts of it are all the same. It's a disk that spins with lines on it. You're counting the lines.
That's
Yeah, it's
interesting.
pretty
It's
cool.
almost like human beings with different languages. Sounds like your product can speak different languages, but you boil it all down, it's the same. The
I
same.
wish that was true. Um, Unfortunately, they've made it so that you can trademark your language. So there are
Oh,
languages we're not allowed to speak.
right.
But for the most part, absolutely true. Yep. Yeah, but they're all giving the same information. And in elevators, it's probably worth mentioning there are two flavors, and the flavor I told you about is an incremental, and I won't get too much into the weeds, but there are two. There's vanilla and chocolate with encoders, and that's it. The first one is incremental, where you're just counting those ticks, if you will. You're
Sure.
interrupting the light and counting. Hey, I counted 60, I had 60 lines, I did a turn, or I counted so many lines over a second, and I can guesstimate, well, every line is an inch, and I counted 10 over a second, I'm moving 10 inches a second, that kind of
Right.
thing. So that's your speed, right? And in an elevator, you would use an incremental encoder for the most part because you're just looking what is the speed of the car.
Hmm.
But there are non-rotary, and now starting to see more rotary encoders that are used for position. And the difference with that is it's more like your watch. So the disk on the encoder has a unique code,
Okay.
kind of like
Hmm.
our watches, 1, 2, 3, 4, right to 12
Tell what
o'clock,
time
right?
it is. Sure. Sure.
Exactly. So you can look at your wristwatch, and if you have an analog watch, and you can see what time it is. You didn't have to watch it move to there. An incremental encoder, you have to listen and catch every count, or you don't know where you
Mm-hmm.
are. They're all the same, all the pulses. So an absolute encoder, it spits out a word value that tells you where it is. You could stop listening to it. You could unplug it, turn it, plug it back in, and it's going to tell you still where it is in a position. Some elevator applications require knowing the position of something, not just the speed, and that's when you'd
Sure.
use that encoder.
Yeah. Yeah.
Maybe
Yeah.
more
No,
than you wanted, but
no, it's fascinating. I mean, I haven't ever worked on an elevator or been inside the shaft or any of that, but I'm always fascinated to just, I guess, in my mind and envision how it works. Seen pictures, some videos or whatever. But it is always intriguing to just wonder, like, how does it know where to stop, right? How does it know, the next floor? Yeah, I assume they're the, a consistent height, but I know that's not true because a lot of times the ground floor of a big building, they got a higher ceiling or something. So being able
Correct.
to dial in those locations sounds like that's exactly what your product is helping do.
Correct. When it's a rotary encoder, there are elevators that use like tape readers where they actually
Mhm.
put, basically a roll of tape with unique code all the way up, kind of like reading just a very long barcode.
I'm going to say it sounds like
Position like
a
that.
tape measure that they've pulled out and just kind of slapped it
That's
on the wall. And
exactly
it's
what
like,
it
oh,
is.
we're at 8 feet 2 inches. That's where we need to be.
Exactly right. But that's a long piece of tape to install, So there's pluses and minuses, but that's another way that they position a car in
Mhm.
a shaft.
That's fascinating. That's fascinating. Um, what do you love most about your role, your company, what you're doing now?
Well, I've got a new role as of June of last year as sales manager. So now I'm covering the Northeast, Southeast, and Midwest, which gets me into uh, more industries than I used to be in
Okay.
when I covered just the Northeast, which was Maine down to Virginia over to Michigan, Ohio, Kentucky, Indiana. And doing that, a lot more exposure to the elevator industry, for example.
Right.
So, my favorite part of the role, probably from that upbringing, fixing engines, is I love getting into the nitty gritty. I love seeing a solution that others gave up on, a problem, I mean, that others gave up on, and trying to find a solution to that. The elevator industry, some of the unique features, yeah, I can make it seem the encoders are simple, and what they do is, elegantly simple, but they can't fail. Nobody wants to be in an elevator if the encoder fails, right?
No. Right.
So there's a lot with the mechanical mounting of an encoder. Maybe there's redundancy of signals. Maybe there's two sensor heads. There's a lot of different ways to solve the same problem depending on who's designing it and what features they're looking for. But elevators are one of the industries that I take a lot of pride in. Of course, I love packaging and boxing and gluing as well. But elevators are important, and it's a serious industry in that it's not tolerant to mistakes.
Right.
If somebody from packaging calls me, oh, we had a run of hot dogs go bad because the sealer was sealing too early. All right, well, we lost some hot dogs. But in the elevator industry, it's much more requires much more consideration. So
Oh,
I
absolutely. I'm,
really
I'm sure
enjoy
you've
that
got
part of it.
some, redundancies and just making sure that you're not losing position or track of speed, or obviously you got, people's lives, people's, loved ones,
Right.
and um, everybody, you're right. It's a bigger deal.
Yeah, it's something we take pride in. We're very unique versus our competitors in that we're much smaller. Most of our
Right.
competitors encoders are just one product line, and they have many
Okay.
others, vision
Uh-huh.
systems, and all sorts of things,
Right.
things you wouldn't even expect to be related. All we do is rotary, and probably 60 to 65% last I looked at what we do is custom. So we aren't selling parts out of a catalog.
Mm.
Not vacuum cleaner salespeople, I guess you'd say.
Yeah. Yeah.
Most of what we do requires us to go in and come up with a custom solution. And because we build everything in house, not to make a sales pitch out of this, but it's what makes us different. We're machining the parts, we're populating the PCBs and everything. We can really offer unique solutions without breaking the bank. And that's where we excel in the elevator industry.
Oh, that's fascinating. I mean, part of my brain is wondering, well, w- why would everything need to be custom, right? Is there not a way to that 90% of them are probably the same, and you can just buy vanilla, or does it need to be custom every time?
Yeah, not every time. It depends who we're working with. We'll do elevators for large contracting companies that do
Mm-hmm.
repairs, and they're trying to replace encoders that were manufactured by companies 20 years ago. And I'll use the name DRC. Did a lot in elevators, and I'll use their name because they don't exist anymore.
Okay. Yeah.
So you can't find
So
those
this is like
encoders
a
anymore.
mod, right? They're looking for something to.
Exactly right.
Okay. Okay.
Exactly. But there's a lot of those elevators out there, and if they can't find an encoder to fit that unique, mechanical mounting, whether it be inside of a pulley or a shiv or on the back of a motor that was designed then, they're not going to want to replace that large motor because they can't get an encoder that mounts correctly. So there's a lot in the mod industry. In the OEM side of things, obviously we have a major manufacturer. I'm in Connecticut, right up in my state, and an encoder is a sensor just like a proximity sensor. It is, you don't choose your encoder and design around it. Generally, you choose your motor and
Sure.
you've got constraints of where you're installing this thing, but you choose your motor and your gearbox and your major components like that, and then you pick your encoders to fit. But hey, sometimes you end up with a motor that's the right size, it's everything you need, but you've only got a 2-inch clearance between the motor and the back wall or something, and you need that encoder to have a low enough profile.
Interesting.
We get asked a lot to fit the encoder within the inner diameter of an electromagnetic brake, and there's constraints and temperature considerations and a lot to go with that. So, yeah, it's very much required, and I think the biggest reason because they choose us last. We got to
Okay.
fit in whatever
You
they
got to
designed
make it
already,
work, right?
right? Which is
That's
good.
fascinating.
I don't
Yeah,
want
yeah.
them to choose encoders first because then they'll buy something off the shelf, right?
Right.
And there's a lot of people selling encoders off the shelf.
Right. Well, and you talked a little bit about, solving unique problems and sounds like there's obviously a lot of opportunities for creativity and thinking outside the box. And I guess along with that, what, as you look forward, what are some of the, uh, I guess the things that you're seeing, oh, hey, this could change the encoder industry? Are there certain technologies that as you look ahead, like, wow, that would be different.
Yeah, I think so. For example, optical encoders, which is what we make. The majority of
Mhm.
what we make is optical. So you have a glass disc that you're shining light through.
Mhm.
And there are other technologies out there now that haven't existed for as long. Whether that be capacitive, inductive, magnetic, all different ways to accomplish the same thing, get
Sure.
pulses in a circle. But most of those are not anywhere near as accurate. So
Okay.
if you're purchasing an encoder where accuracy is a consideration, and we're talking orders of magnitude,
Sure.
typically less accurate for these technologies. So I don't consider them game changing as much as there are new solutions for the lower commodity end. Maybe you're building a vending
Okay.
machine. You don't really care how accurate the claw is to get the kid's toy out, right? Or something like this.
Sure.
But there's some new technologies. One of them is reflective technology, which we offer now. And that technology allows the sensor and the LED to be on the same side of the disk. Because before you had an LED shining light up through, and your disk is going by, and then you had your sensor on the other side. So now you got a
Okay.
PCB on each side of the disk.
Mm.
And generally speaking, there's an air gap in there that's very thin. We're talking, a thousandth of an inch or somewhere thereabouts
Wow.
between the read head and the disk. So one of the common failure points for encoders, including in the elevator industry, when you're running on large motors that expand and contract a lot when they warm up and cool down,
Sure.
is disk crashing, where the disk actually contacts the sensor head, and as soon as it does, it wipes the lines off the disk.
Right.
And that is a problem inherent in that design in general with any manufacturer's encoder. This new reflective technology, which is really neat, it shines a light at an angle onto the disk and then bounces back up to a sensor,
Answer. Mm.
and it allows for much larger air gaps,
Mm. Okay.
in the tens of thousands or larger. So we basically have completely eliminated the potential of a disk crash with this technology. So I see that really uh, uh, being implemented wide. Once you see the technology out there for a while and people begin to trust it, as if you're an OEM of elevators and you're looking at common failure modes, you can like cross that common failure mode off your list. It's not going to happen
Yeah.
again. I think that's
That's
pretty big.
awesome. Yeah. Well, I mean, what happens if you get one of those disk crashes? I mean, if maybe you're riding the elevator and all of a sudden that comes in, does it stop? Does it plummet? Does it blow up?
Yeah,
I
that's a
have
good
no idea.
question. Everybody should worry about that for the rest of their life when they get in an elevator. Now,
Yeah.
that's where
Is the
safety comes in.
Sure.
Elevators rely on redundant feedback. There's usually more than one encoder. There's a lot of different ways, so I won't nail it down to one specific, but there is error detection uh, uh, potential built in.
Mhm.
For example, that we talked about the lines in the disk. I could have 1,000 lines in the disk, but I have this other line called an index pulse. It's one pulse per revolution.
Okay.
So my control sees that pulse and then it counts, and it better count to exactly 1,000 and see that pulse again. So if it counts to 980 because maybe there's a crack in the disk now, then you'll get an
Interesting.
error that there's something wrong with the disk. But what do you do in the middle of that? Still went a full turn. There's ways to design redundancy in. So you can have 2 disks and 2 read heads, for example, or maybe 1 disk and 2 read heads. And if you have one fail, then you will see a deviation between the output of the two. They should be
Hmm.
outputting the same exact signal at all times. If we have 1 disk crash or crack, then you'll have a difference in signal and you'll e-stop, as we say. You'll have a safe stop right away. So that's typically redundancy is everything.
Yeah. Yeah.
A new word. I haven't heard it in elevators too much, but it's very large in automated manufacturing, and I would think we're going to see it catch up there. And maybe it is. I just didn't hear it. I don't know everything. But is diversity of technology. That's
Okay.
that's a new buzzword for safety, and that's where you actually use 2 encoders
Of
in a
different
redundant
technology.
pattern of
Okay.
different technology. So we have a magnetic encoder for that reason, in part because we build redundant encoders where the main encoder is an optical disc, and then we have the secondary magnetic kit encoder installed on the back, and that's for providing that redundancy, error checking. But because they share no technology, they can't have a common fault between them. You're not going to have, hey, look, the battery failed on this one, but on that one at the same time because it's the exact same encoder, right?
Right.
And that's considered the highest level of safety.
That's awesome. Yeah, it reminds me of I remember taking a statistics class in college, and kind of that thing that once you have these redundant backups, the likelihood of failure goes down just crazy. I don't remember the
Oh
numbers,
yeah.
of course, but it was like if this one's 97% up and this one's 97, the likelihood that they're both going to fail at the same time is minuscule, and it was kind of mind-boggling how that.
Yeah, it's we have to discuss a value very often, MTTF. I'm sure a lot of people have heard of mean time
Right.
to fail, but there's MTTF little d for mean time to destructive failure, and
Mm.
that's a very common number you need nowadays when you're working on a safety application. And you're talking about this number that we have to generate. It takes a lot of math, and I'm a biology major. Everybody, I don't do the math, but that number is usually 500, 1,000. We just did one was over 2,000 years expected
Oh my God.
between destructive failures, and you need the numbers in hundreds of years if you're going to get a product in. So it's the statistics behind it are there
Yeah,
in
yeah.
the
No,
encoder world.
that's fascinating. That's fascinating. What do you have like a favorite professional moment you'd like to share?
There's been a few, and they all are along the same thread. One of them was an automated guided forklift. So, fully autonomous
Wow.
forklift drives around
Hmm.
the factory, moving boxes. Think the big box names, right?
Yeah.
And they were looking at doing angular measurement on the driving caster. So, if you think of a typical stand up forklift you see at a Lowe's or Home Depot, and somebody has the handle that
Sure.
spin, and if you look under it, it's these 2 caster wheels that just rotate.
Okay.
It's casters in the front and then just this one big caster in the back. They want an angle on something like this. And they had a proposal of how to do it and came looking for a product from us. And I said, absolutely, we can do that for you. You'd be looking at this, take this long, whatever. Hey, by the way, have you considered, on old farm tractors,
Here it comes.
I've seen it done like this, and what do you think of that? Could you fit it because you're going to have your cost? It's more reliable. You're only using one gear, that kind of thing. And I'm not an engineer, and I say that up front. And they came back to me a day later and said, Jared, we really like that idea. And they ran with it, and we've sold thousands of these things now. And so that's a proud moment because I walk into stores like that, and I
Sure. Of
can point at it, and I show my kids, hey, your dad,
course.
he's always on his headset. It looks like he's telling stories, which I am half the time, but I actually do something. We had another one. It was for cancer treatment.
Right.
And so any of those, we ended up doing a very custom encoder for a solution they didn't think they'd be able to find. And it was for treating prostate cancer.
Wow.
And this actually goes on the device that determines the angle to like zap it.
Wow.
And so it's just a really good feeling when you see that you played a role in something like that, you
Yeah.
know?
Yeah. And for something, especially that most people A, don't know they exist, B, will never see one in their life, to know that you've contributed to making something possible that
Yeah.
that could really serve them.
Encoders are everywhere.
Yeah.
And anything that moves that doesn't have a human being, A, moving it, and B, verifying that move. Because there's a lot of things that human beings move and still need an encoder. Some of our biggest customers are mobile equipment manufacturers of cranes and fork trucks, and our encoders go on the manually operated ones. So we're working on with a customer now who uses 2 or 3 encoders in their salt trucks. So when you see your
Yeah.
town or city salt truck going down the road, there's encoders on there. You go through the airport, and that machine that puffs air at you, there's an encoder in the top of that.
Right.
So yeah, we get in a lot of cool things, and they're not always sexy to look at our catalog. You don't go, wow, this is like, amazing stuff, but it really is for what we do and what we get
Well,
into.
the end product, I think, is where you get the wow factor, right? I mean,
Yes.
it's just like, wow, that's amazing that that's possible. I mean, somebody was, and maybe it was you, I don't even remember. Somebody was telling me that, the steering column on my vehicle really, it's not a direct linkage anymore, but it's encoded. It's being watched by all the electronics that, when it tells me, oh, hey, you've gone over the line and you need to learn how to steer, kind of thing, that it's encoders going, oh yeah, it's Matt driving again. Let's
Exactly.
give him a notification.
Right. Right. That's exactly right. Yeah. So that's been the most fulfilling. And the people I've met, because you're a nuclear engineer, which did happen. And this nuclear engineer was a professional engineer and had his college doctorate,
Wow.
is a doctor of nuclear engineering in his 80s. So he was involved in some of the major reactor designs that are operating today. And when people like that are working on a project where they need an encoder, even as an engineer, they don't want to know the nitty gritty. They want to
Yeah.
know from me, how's it going to fit? Can you modify this? I need these signals type of thing.
Tell me,
Um,
can it give me the output I want, right? I just need to know,
right.
how this satellite. I remember watching the video of how they, I think it's the James Webb, whatever station and satellite, but it's taking these amazing pictures, and we watched it unfold and basically position itself, and I'm sure there were a ton of encoders just making sure
Oh,
that
I'm
every
sure.
single part piece
Yep.
happened at the right time and in the right way, and then stage one, stage two, and fascinating. Yeah.
It is, yeah, yeah. You need vacuum rating. You can't air gas anything. We know about space, and it's a lot of fun. So, but I'm telling you, people would find some of the conversations we at Encoder have had, getting involved in the motion of every application under the sun, because you meet somebody like that engineer, and you get them. I'm a very curious person. I've been known to run meetings long, wasting time because I'm too curious about what people do, and there's just a lot of neat stuff out there.
What skills and education would you say are most valuable for someone if they're fascinated by what you do?
I think experience with a hands-on application. A lot of universities, and I've been out a long time of school, but they do internships and things.
Hmm.
But I have found when I visit these, companies everywhere. But I will tell you, I know a lot of successful people, especially students who had to work. And I was one of them.
Hmm.
College wasn't free. It's not free
Sure.
now. Um, and there's a lot of opportunity, particularly if you live in the Rust Belt, if you live in anywhere in New England, in New Jersey, New York, areas that have a large legacy industrial base.
Okay.
Where the old ball bearing factories are, and there is a lot of machine tool companies and engineering firms, manufacturing companies that manufacture with automated equipment that are desperate for employees. And if you want to be a manufacturing engineer in the elevator industry, but go work at the companies that build elevators, you don't need to start there. Go find a role, and it'll be easy to find where you can get your hands dirty working on machines.
Right.
The best engineers I meet in the field, they're typically running the teams. They're typically engineering managers. Because, by the way, for the most part, you get a degree in engineering, you're an engineer, right? But to be
Sure.
an engineering manager, you got to prove you know how to lead people and solve problems.
True.
And you don't learn that at college. And a lot of engineering managers I've met came from backgrounds where they started doing something with their hands, having that real world application. Work hard, and you'll get there.
Yeah, yeah. Thank you. That's great advice. It is a unique, just that, like you say, the electro, the mechanical, the, sometimes hydraulic, the all the pieces that come together, and you're right. It does seem more almost rare that you can find a place where can you learn all those things and get your hands on them, because, you're not going to get your hands on them in a textbook. You'll see a picture,
Right.
you know,
And that's
online.
not knocking this generation. This generation's at a disadvantage, and my generation was the beginning of that. My father's generation, I guess that'd be the baby boomers. Well, you will meet a lot of them today as they're getting into retirement, and ask them, "How did you get into this?" And a lot of them will say, "I grew up working on cars."
Sure.
Because in the 1970s, you had distributor caps, you had carbureted engines,
Sure.
and you could work on your car. You can't work on cars today. So
Yeah.
kids today, a lot of the stuff in their life is now disposable. There's no reason they're not getting those opportunities to get out their socket set and open up the cylinders and increase their compression ratios and all these things. And they're not doing that, so they're not getting those skills.
Yeah. No, it's a good point. So, as we wrap up, Jared, what else would you like to say? Anything you'd like to give to our audience before we sign off?
Do what you love. You know, uh, I had a very jagged path. We didn't even get to my time in the service, which is good. But I've done a lot of things. I've worked for the government. I've worked for big companies. I've worked for small companies. I've worked for a lot less money, and I've worked for a lot more money. If you don't like what you do, don't do it. That's it. Put your family first, put your life first, and do what you like.
Said. Well said. Jared, thank you so much for being with me today. I've enjoyed every minute, and wish you the best as you continue on your path.
Thank you very much for having me.
Thank you for listening to the Elevator Careers podcast, sponsored by the Allred Group, a leader in elevator industry recruiting. Please visit our YouTube channel at Elevator Careers, or check us out online at elevatorcareers.net. Please like and subscribe, and until next time, stay safe.